Okay, so your test 2 will be looking at the rigid body, like what you learned in the CL1 particles. But now we will repeat the same formula, but now we apply for the rigid body. Okay. Now what's the difference between particles and rigid body? Particles, like you see the whole body from your head to toe is at one very big dot or one body. Start from today, this chapter 5. You look your problem as rigid body, means head is head, body is body, left hand, right hand is different, your feet is different. Then you combine the effect of your head, your left hand, right hand effect on the whole system. Okay, so rigid body, most of the time, the dot of the center of gravity is important. Okay. Anyway, in your static, you already know how to calculate the centroid. So in this chapter, you don't need to memorize. You will see the appendix at the back of the question. You just need to refer to the table and then copy the formula and substitute. Okay. For your coursework, your assignment, the question already inside the canvas. This one, individual assignment. I forget whether I got 10 question or a few question there. You already can start to answer some of the question. Pass up maybe week 13. I need 1 week to sort out everything, and then I need to give you feedback for your coursework. So I need at least 1 week. So give me some time. So then we will do revision on week 14. The last week we'll do revision. Okay. Lab report, you need to check with Dr. Reza. So this start from last semester, no longer 5 question, is 4 question compulsory. So no choice, you have to answer 4 question. And the question is following the CL that just now. Okay, so this chapter 5 is a big chapter, but I split into half, right? So we look at some axis first, then we go to the motion. Right, we look into the axis first, the axis effect, then we go into motion effect. For rigid body, means body, right? You have 3 types of motion. You have translation. First type, translation, means moving in the straight line. Can move to the left, right, up, down, but in the straight line. It can be at one angle, but in the straight line. Okay, keyword is straight line. So the first translation is first motion is called translation, or sometimes some textbook will use rectilinear translation. This is what you learn in your chapter 1 and chapter 2. Everything move in a straight line. So this one also happen in the body, rigid body, right? First motion. For example, you look at this diagram. So this body, okay, so for particles, we always look at 1 dot. But when they come into rigid body, we will study 2 dots on the body. Okay, 2 focus point on the body. So for example, these 2 points, after some time, this body, these 2 dots move in the straight line. It will arrive from start location to end location. This motion is called translation. Means you can draw a straight line using a ruler one. That one is called translation. Translation also can happen in the curve motion, as long as you can trace the 2 lines. This one also means a translation, but in the curve motion, curvilinear motion. This one is rectilinear motion. But it's both are also under category of translation. Okay, this is on the same plane. This one happened in the same plane. In rigid body, we start to look at plane. What I mean by plane? So this is 2D plane. So everything, all this motion happen on the plane. Okay, happen on the plane. Second type, called rotation. This one, particle don't have, you don't see rotation on the particles. But when you look at the 3-dimensional body, you will see second motion called rotation. Rotation must define by 1 line called rotation axis. There must be axis for it to rotate. The third type is a combination between the translation and rotation. We call it general plane motion. It's a mixture between two. Okay. So there are three types of motion. So in your analysis, you need to consider these three motion. How it start from original position, then how it reach the end location or end orientation through the combination of translation, rotation, how it turn here, turn there, then at the end orientation. And that is what we want to study. Okay. Now, a combination of general plane is like this. So it can be linear, then rotate. Okay. So this one, you can see it as two motion. How to reach these two dots into here? It can be moved to here, or it can move to this location, then rotate. Okay. So two motion. So two motion. Then we will use these two motion to derive equation. All right. Now, chapter 5, we will look into machine motion. For example, you'll start to see all this linkage. You'll see piston, you will see round bodies, you will see linkage like this. Okay. So, for example, this piston, mechanical student, you are quite familiar, but maybe civil, you're not very familiar. Piston, you have a room for that, but this room is fixed, so can only move in that direction. For example, on the table also. That one also means rectilinear translation or translation. This one is this link, this arm can only rotate like this. So this is also translation, but rectilinear translation. Okay, this one, this one rotation. Okay, this one, this one. This link body is moved in the curvilinear motion. It moves like this. Okay. This is the general plane. General plane, this means what? This one rotate, but this side translation. So it's this link, this body here got two motion. Okay. So you look at the two dot. This dot is rotating, but this dot cannot rotate. It can only go left, right. So it's a combination of two. So chapter 5, you look at the body and you look at individual body. What happened to that individual body? For particle, you see this one as a whole system. But now you need to break into individual components. Okay. So we start derive equation. We start from the bottom one. This is a plane of xy, the screen here, xy, and then with the origin here, this dot. Then we have another axis that we put x prime or x comma, y comma. This one, this axis is moving. So you have a reference point, means observer point, or there is a fixed point for you to refer to. It's like you're observing, you're standing here, then you're observing something happen. So here, one axis fixed, one axis moving. So when the axis is moving, we call translating coordinate. Then you start to link the location in vector form. In this case, referring to O to B, O to A. By using R sub B, R sub A. By using vector arrow. So arrow direction is important. So from origin looking to the point B, origin looking to point A. Since this is a vector, you can draw the differences between these two vectors by drawing from the tip of arrow A to the tip of arrow B. So from here, it's just an application of vector chapter. Previously, you use double line, double arrow as a resultant. Again, you have a start point, end point. Okay, so you need to write the equation of vector. Sometime plus, sometime negative, it depends. So here, on the left-hand side is whole result or motion from start to end. Start to end only. So at this point, you see this one and this one. So this is, let's say I label as A lah, vector A. So vector A, you write on the left. Then the right-hand side here is how you get the result or process. So how you get from start to end point. So this you need a combination of something. So here you start from a start point here, go here, then reach here. So on the left-hand side equation, you write B plus C. It must come with B first, then C, because the sequence also important. If you write C plus B, mathematically it looks wrong, but it doesn't affect your final results if you put in the correct location. Okay, if you understand what I write on whiteboard, you look back at the slides, you should be able to derive the equation for this one. Okay, before you derive equation, there is something maybe I need to recap here. What mean by RB stroke A? RB stroke A is what you look. A is your source. This one is from where you look to where or your target. B from your source. Okay. So this one RB stroke A means you're looking at B from A. Or sometimes my trick in all my dynamic class, I just ask my class to convert this one into negative. How? You write RB minus RA. Convert this slash into negative. If you cannot remember, or you don't know how to draw this one. Okay? So it always work lah. It always work in that sense. So the position already explained. So at the end, you arrive at one equation, which is this one. RB equal to RA plus RB stroke A. If you rewrite this equation, you pull RA to the left-hand side, you are the same as what I write on the whiteboard. Okay. So normally either this one is missing in the question or this one missing in the question. Usually it will give you starting point and then something missing. Okay. Okay. Once you have position, you know that from position you can derive into velocity. Velocity ds dt. So you have position. So r dot or dr dt. So dr dt, this one, you arrive at dr dt, you get vb. Dr dt, you get this one. And this one is rb stroke a. So you need to do differentiation of vector rb stroke a. You can also write VA, VB stroke A for this one. But because of mathematics steps, I still need to explain to you what happened to that one. So this one, since that magnitude of RB stroke A is constant by a definition of rigid body, what mean by RB stroke A? For example, the distance between your mouth to your ears or to your eyes is always same. right? So if your two eyeballs distance always same and you time differentiate it, you'll get 0. For rigid body means the whole of two sides or two pin doesn't change most of the time. Okay, so this, when you do mathematics, this one equals 0. So what does it mean? It means that for rigid body, velocity B was same as velocity A for rigid body. Okay. However, the position will not same. Position, you still need to know how to derive. Velocity, if you time differentiate it, you'll get VB equal to VA. What does it mean? It means velocity of B and A will be the same direction and same magnitude. Same like you're walking, the speed of moving of between your left eyes and right eyes will be the same. The velocity will be the same. Right? The velocity will be the same, direction same, magnitude same. This one happened in the rigid body. Okay, the third one, acceleration. So acceleration is dv dt, same. You arrive at acceleration of B was same as acceleration of A. Same like you take your ice ball, left ice ball, right ice ball. When you walk, both eyeballs accelerate at the same value or same magnitude or same direction. Okay, again, see this one as vector. See what this one as a vector component. Okay, so if you're able to understand all this, we will start to apply all this equation by using right-hand rules. Okay, how you know this one is chapter 5 question? You will see R, you will see theta, you will see omega, alpha, and d theta. Okay, this one. So all rotation have one rotation axis, and then we look at a point where does it rotate. And if you follow your right hands, your angle, if you look from top, the rotation anti-clockwise always positive. So the angle, the change of angle, it will be positive if it's following your right hand rules. Okay, so every time when you solve chapter 5 question, you're actually looking from the thumb of your hand, from this direction. It means you're looking from the top. Then you see what happened. Okay. So angular motion. Angular motion, point without dimension cannot have angular motion. Only lines or body undergo angular motion. So chapter 5 is for rigid body. Particles don't have this angular motion. Particles only have angular of momentum, like what you learned in the last lecture. Okay, the rest I'll just go very fast. As long as it's in 3D and you see R, all these things. So angular position, we look at the changes of angle. Angular displacement, we displacement is a changes of angle, d theta. Okay. And you know how to find magnitude lah. Okay. In this case, you'll see the question of rigid body, you are given in revolution. How many revolution? But you need to change revolution into pi and radian. One revolution 360 equal to 2 pi radian. You need to know lah. Do conversion from revolution from the question. Put this one, this value into your calculation. Okay, one revolution equal to 2 pi radian. Direction, use right hand rules again. All right. Okay. Now I hope you can remember what you learned from particles, the 3 Newton equation. The first one, V equal to VO plus AT. Second one, V square equal to VO square minus 2A delta S. The third one, delta S equal to U, equal to VO T plus half AT square. I hope we can remember this one. I will not go very deep into derivation. You can look at the derivation when you are free. What I want to highlight, this is from particles chapter. When you translate into rigid body, you start to see theta, omega, alpha. What else? Okay. This theta is a change of angle. This is a displacement equal to displacement like what you learn in your particles S. This one, omega, will be velocity, is an angular velocity, change of this one. Alpha is acceleration. Angular acceleration. All this angular lah, angular. Okay. So if you know these three, displacement, velocity, acceleration, go back to this 3 Newton equation, change accordingly. V become omega, A become alpha, time still the same. So from here, if it's a rigid body, you change this one, V equal to omega O plus alpha theta. This one, V square equal to omega square equal to omega O square minus 2 alpha, acceleration is alpha, delta S is delta theta. This one, change of S or S2 minus S1 is the same. So delta theta equal omega O T plus half alpha T square. Important thing is this one. And these 3 Newton equation translate into the rigid body term. Same concept, but now rigid body is on changing of angle. And everything you use the word angular. Angular displacement, angular velocity, angular acceleration. Okay? So I don't want to confuse you with the derivation steps, mathematics. At the end, you will still see these 3 results. I just summarize, I think, more than 10 slides later, you will see. Okay, I won't ask you how to derive the equation. I'll ask you how to apply the equation. Okay, if you're interested, you can go. So, again, omega is velocity, but it's angular term, angular velocity. So velocity is what? ds dt. So what is s in rigid body is theta. So d theta dt equal to omega. Following right-hand rules anti-clockwise positive. Okay. So every time you solve rigid body, you look from the top, how it rotates. Okay, how it rotates. So same with, only need to highlight the unit is radian per second. You are looking at radian, not degree. Radian. 360, 1 revolution equal to 2 pi radian. Acceleration still same. If you understand what is acceleration is a time differential of velocity, dv dt. But now we are in the in a rigid body. Change the word of acceleration into angular. So just change the velocity into omega, d omega over dt equal to alpha. Again, following your right-hand rules, anti-clockwise positive. Okay. And of course, you can still apply what you learned in chapter 1 acceleration also can write in the displacement format, where you double differentiate of your displacement. D theta square over dt square, also alpha. Right? This one is what you learn in chapter 1 and chapter 2. You apply in angular. Okay. So if you get, if omega decreasing, then you will, sometimes the question give you hints. If you velocity decrease, means you have a negative a, you deaccelerate. You deaccelerate. So you have these two, and again, what you learn in chapter 1, you know that chapter 1 you are able to link dv dt a equal to dv dt, v equal to ds dt. You freeze the time. You write dt equal to dv dA, dt equal to ds dv. So you arrive at a ds equal to v dv. This one you learn in chapter 1. Do the same. You see acceleration change to alpha. You see the s change to theta. V you change to omega. This one is omega. Okay. So this is what I want to highlight. We're actually changing the rigid particles into rigid body. It's the same. If you have constant angular acceleration, like what you have in the 3 Newton motion equation, if you have constant acceleration, you can do integration of what I write on the whiteboard just now. You can derive the same equation, but I don't go into that detail. So you can still use these 3 equations. Under one condition, your acceleration must be constant, like what you learn in your 3 Newton motion equation. Okay, 3 Newton motion equation you can only use when you have a constant acceleration. Okay. So just remember this one. Okay. Now we go into okay. Now we link the particle chapter into kinetic chapter. In particle chapter, you learn about VA, right? This one particles. Now you are in the angular. Angular, you have theta, omega, alpha. So this one you have SV and A. So you want to link between these two worlds. Previously, we all communicate in the velocity, but now we want to communicate in the layman term. For example, in body, you cannot tell someone, or this body rotate in the a few revolution per minute. It's very hard to imagine, right? So you want to communicate this angular into a layman term or particle term, people easier to understand. So if you have omega and r products is equal to v, just need to remember this one. The derivation may be a bit hard to explain. I'll just keep. If you're interested, go and read all the diagram is there. So when you take omega with its angular velocity, multiply by the r. What is the r? R is the radius of that circle. Okay, radius of that circle. You take omega multiply by r, you get v, velocity. Left hand side is normal velocity. Right hand side is angular dimension. Okay. Before we go into next equation, you know that because you are working with radian, you need to recall theta, r, and s. This small section of this one. If your theta is in radian, you can write s equal to r theta. So the small changes of s will equal to r will be the same, circle will be the same of r, but the changes of theta will be small. So this is a linkage lah. Sometimes you can integrate, or sometimes you don't need to integrate, straight away use s equal to r theta. Again, v in the particle chapter, when you move in circular motion, your v always tangent. Okay, in the circular, your v always tangent. You always have vt in the circular motion. So here, what you calculate this one, omega r is actually calculating vt. So since you have two ways, either you do scalar, you take omega multiply r, you get a scalar unit, or sometimes you do in a three-dimensional, you have to use vector analysis where cross products, omega cross rp, where you need to recall the matrix form. Right? When you do cross, remember this circle, ijk, anti-clockwise positive, clockwise negative, I multiply I cross j, you get k, and so on. You need to remember this one, for rigid body. V equal to omega cross r. Yeah, you take omega cross r. This r is to the distance to the target that you. The question asks you where does the interest point r, the interest, the radius from the circle of or circular motion. Okay, the rest you read. I just highlight r cross rp doesn't change, doesn't same as r cross omega. So here, this is omega. Omega cross r. This is omega. Omega axis is here. So omega cross to r. Okay, omega is something turning. Turning have an axis. So you're referring to the omega axis. Then you use your right hand rules lah. So that axis cross to the radius of r vector, omega cross r. Your thumb is pointing that way. Okay, so your thumb is representing the tangent velocity. Yeah, omega cross r, your thumb is pointing tangent direction of velocity. Just remember that. Okay. The next one is what you already know. Recall. Circular motion, you have tangent and normal acceleration. Normal acceleration is v squared over rho, that you already know. At equal to v dot or v dv dt. You are actually taking tangent velocity. And you compare side by side. Rho equal to r. Rho equal to r. V equal to omega r. Alpha equal to d omega dt. Left hand side is what you learned in particles. Right hand side is the current chapter. Rho that you learn in the particles is called rho, but when it comes to rigid body chapter 5, it becomes r already. Okay, so if you look at the question, give you calculate rho, it means it's a particle chapter. You don't use chapter 5 equation. If the question asks you to find r, means it forces you to go into chapter 5 already. Okay, v equal to omega r, alpha equal to d omega dt. So this one, usually you need to be good in differentiation. Omega always in the equation form. Okay. So omega, usually omega equal to 3t plus 3 something, or t square plus 3, something like this. So you need to know how to do differentiation in time series. Huh? Sorry, in a time differentiation. Okay. Okay. So this side, if you substitute v equal to omega r, so you d omega dt is alpha. R do not change. You pull out the R, you get alpha R. An equal to v square over rho. You know that v equal to omega r. So you square, you get square omega, square r, divided by rho is r. You cancel the r, you get omega square r. So I just add a note here. On the left-hand side, you have an and at. An equal to v square over rho. At equal to v dot or dv dt. When you change from particle into angular or rigid body, this one, an equal to omega square r. At equal to alpha r. So don't confuse with this one. Don't confuse the left-hand side and right-hand side. And don't confuse between these two. An1 always have a square. At don't have square. Always link with alpha acceleration. Yeah, remember, there are two different sides of this one. So if the question you see omega already, or omega equation, you know lah, you are working into angular dimension and chapter 5 onwards, and not in the particle anymore. So these are the differences lah. Okay, so this slide is just tell you that still looking at as a vector dimension. If your speed is velocity, if your velocity increasing, acceleration also increase, but at at the same direction of av. At is this one. At same as your v. Your v is always tangent to the circle, so at will always same as your v. But if the speed is slowed down, the velocity slow down, your at will be opposite direction of av, because your acceleration become negative already. Okay. Okay. So here same lah. An always pointing to the center of the circle. An always pointing towards center of the circle. Okay. Now this one is a little bit derivation on the equation. A equal to dv dt. So multiply dv equal to omega r. dv equal to omega r. Or in the vector form, or in a vector analysis, in three-dimensional analysis, no choice, you have to use cross products. So v equal to omega cross r. Omega cross r. We always take omega cross r. Omega, look at the axis of the omega, then look at your right hand. Pull from the omega axis to the r. So that is the direction of your vector. So when you do cross and dt, you actually have two sides of equation you need to solve, because it's a chain rules. It's a chain rules. So, but this is not important. I will not ask you how to derive. At the end, this one you can look at. You can go and see. I don't ask you this one. Acceleration at the end. Okay. At the end, I want you to remember this one. A equal to AT plus AN. So AN equal to alpha R cross R minus omega square R. Some of you might question why negative here. Because in rigid body, you know that your N is pointing inside the circle. But in rigid body, you are looking at one dimension called R. Your R is positive going up. So these two vectors actually go opposite of each other. So here, when you derive your equation from normal, in the R term, you'll get negative. The vector it just tell you that the AN actually opposite of the R axis, the radius axis. Radius always positive when you increase the R. But the AN is go inside the circle. So in vector form, it should show negative. Yeah. Anyway, this is the important equation. You just memorize and just look at the question, substitute only lah. Mm. Mm. Okay. So for this one, I will erase. A equal to AT plus AN. So A is alpha cross R plus negative omega R squared. Hmm? Which one? This one. Oh, this one. I won't ask you this one. I won't ask you to find the angle from somewhere. I won't ask you. That one too detailed for dynamics. I won't go into this one. Unless you do robotics, you do machine design, specialize in robotics, rotation, you design gyroscope and all this, then you need this one. For general dynamic, you don't. It just give you like, if you want to calculate, there is a phi angle you want to find lah, but in your final exam or test 2, I won't ask you. Just this for your info lah. I put here just to show you that actually there's a way of finding it in a phi and all that. Okay. And this is a vector. So vector is square of AT plus square of AN. Then you press calculator, you find. Okay. Okay. For rigid body, for AN, you always remember AN always pointing inside to the center, not go outside the radius. You only need to remember that one. Okay. The question won't ask you to write in the complete form. So don't worry about the negative. The question will ask you find the AT and AN. Find the acceleration in the tangent direction and acceleration in the normal direction. You only need to apply this equation or the one I write on here. AN equal to omega square, AT equal to alpha R. Substitute lah. Okay. Now how to find this one? You refer back to this one. Okay. You can either given in theta, you differentiate with time, you get omega, differentiate time, you get alpha. Now we go into application. Then we have a short break. Okay. All right. Most of engineering, you will see gear. So let's say you have gear, left hand side and right hand side gear. So these two, when these two rotate, the motion or energy from the left will transfer to right. Okay, so you have RB, the B component, the B from center to the interest point, and RC is from center to the interest radius, and A to A is the connecting point. A represent the point for object B. A prime represent the point on object C. So if you break these two gear, you will see this diagram. So this will be the so-called free body diagram for rigid body. You break the object, then you see how does it rotate. So you break these two system, this system into two objects. Then you look at the interest point. Interest point A will, this one is a circular. Circular, you only interested in velocity. So velocity always tangent to the circle. You just go to the point, draw a 90-degree line or tangent line to that interest point. Then the R, same with C. CA go up, go down, right? Then the rest you solve accordingly. This is velocity. What is the purpose of showing you this one? This one is to link V equal to omega R. Where is it? V equal to this one. V equal to omega R. If you have V, you can find your omega. R always same or always given. So sometime omega given, you can find V. Once you find V, you can find ATAN because it's in the circular motion. Here, circular motion, you have ATAN. Okay. And if you're given V, you can find omega. Omega is the most important parameter for chapter 5. You die also need to find what is your omega. Why? Omega will apply for all the point on the bodies. Any point here will give you omega. Same rotation speed. So omega is important for chapter 5 answer. So how to find? Use this equation, V equal to omega R. You'll be given velocity. Substitute or rearrange. V divided by R, you get omega. Use this omega to find what? Omega to find omega square R, you get angular, you get acceleration in normal direction. Alpha, how to find alpha? Alpha is omega dot. Okay, alpha is omega dot. We will discuss example 1. Or you want to discuss 1, then you rest. Okay, means what? Discuss, Okay. I go very fast, so I want you to observe the solution, So you given this object, rotate, round body. So round body, you should have tangent normal direction already. This rope go into tangent direction. You have a force, pull down. When you pull this round object, they should have a rotation. Rotation, you need to find omega already. Now, the first thing in chapter 5, always you need to find omega. So you pull, you have the R short every time you're given the R. You have the acceleration, sometimes give you velocity. This question give you acceleration, right? But you can find omega by V equal to omega R. You have Vt, you have acceleration. Can you link acceleration to the velocity? A equal to dv dt. Sometimes you need to do integration. to get back the velocity equation. Then you substitute there, find the omega. Okay. So you're given so and so typo error here. When theta, this is not u, theta means this angle. So this one, where is the axis of rotation? Go in or go out from the screen? Go in or go out? Look at your right hand. Go in or go out? How you get out? Okay, look at your right hand. Look at the rotation. So it's going in. Axis is going in positive. Your omega axis is going in. Okay. A is given. T is in second. Determine as a function of time. Mean you solve your answer in equation form. The angular velocity of the wheel. Angular velocity means what? Omega. Angular position of line OP in radian means you find the angle. This one, angle. Okay. Remember, S, V, and T. V equal to ds dt. How do you find acceleration? dv dt or ds square dt. If you do rigid body, change velocity into angle. So this one will be omega equal to d theta dt. A is alpha. Alpha equal to d omega dt or d square theta dt square. You're given one equation there, right? But you cannot straight away use that one because that one is on the particle side. You need to transform a little bit. The rest you read, we already explain where is the direction of that one. Okay, so this one is a circular motion, so you have tangent and normal component. So tangent component AT is 4t m stroke s square. AT equation is what? AT equal to alpha r. AT equal to alpha r. You can find your alpha already. Okay. AT equal to alpha r. Alpha r equal to 40. Okay. You have your r. So you move your alpha 0.2 to left hand side. So alpha equal to 20t radian per second. Okay. Nothing complex here. You just apply the general equation, look at what is missing, and then you're moving here and there. Okay. And then give the direction. This one, 20t radian per second square is clockwise, following the motion clockwise. So you know that alpha, you have the alpha equation already. You know that alpha equal to d omega dt. Alpha is acceleration, but in angular form, angular acceleration equal to dv dt. This one is angular, so angular velocity divided by time. You want to find omega, you have alpha, pull your dt to the left, you know what to do, integration. Do integration. Okay, so left hand side integrate what? Integrate time, because dt. Right hand side integrate what? Integrate omega. So this one, you integrate only the limit, need to be careful a little bit. This one, it tell you initial from rest, omega 0, t0. Then you substitute, you integrate 20t equal to 20, move up, t squared divided by 2. The answer for omega will be t nt square. Direction clockwise. Remember the unit. The unit is not meter per second. It's in radian per second. This is the difference between particles and rigid body. Particles always in unit SI, meter, second. But when you switch into rigid body, you're looking at radian per second, or radian second, or radian second square, and so on. Okay, the next one also integration, because it asks you angular position. Angular position is theta. So omega equal to d theta dt. Do the same procedure for integration. You'll get, you move the t cube divided by 3. Just remember the limit. So you start from 0, integrate 0 to angle you don't know, and time from 0 to time you don't know. So your answer will be theta equal to 10 divided by 3 t cube radian per second. This kind of question come out last semester. Last semester, surprisingly, your senior don't know how to do. Most of them killed by this kind of question, because some of you, you're so used to the value, you don't see value mechanics. The question like this will come up. You just need to derive it. Okay, we have maybe 10 minutes break.